Hi, welcome to Dijkstra's algorithm example, which is used to find out the shortest path from single source to all other vertices. Initially, we are unknown about the distance to all other vertices in the given graph from any source vertex. Then we will update step by step of the distance to all other vertices from the source vertex by using the Dijkstra's algorithm. So now we will see the example for the given graph, which is having 5 vertices and 6 edges. The vertices are defined here. Source is selected as a zeroth vertex, and we are creating the 5 vertices by using the Java collections array list. Here, node is having the structure with node and cast. So every node is having two fields. One is the cast field, that is the edge value, and the node value. Okay, so here we will use this cast for selecting the minimum edge for the particular outgoing edges from that specific vertex. So now we are going to add the edge for the zeroth vertex 1 to 9. So here from the 0 to 1 9 is the cast, and from 0 to 2 6 is the cast, and from 0 to 3 5. So like that we are adding 6 edges. Then now we are calling them a method to construct the shortest path by using Dijkstra's algorithm. So here the graph is created with distance variable and connected variable, which is having the set either that vertex is connected with the source vertex or not. Then priority queue to select the minimum edge. Priority queue always have the high priority value in the front. Here this is the front pointer, and here rear pointer. So here the highest priority value, the minimum edge value, for example edge is having 6 5, here 6 7 like this. So minimum edge will be available in the front end. So we will select the high priority value always first in the priority queue. Then we will define the number of vertices. Here we are taking the adjacent list to know the adjacent vertices of given vertex. So here we are assigning values to all the variables declared here, and priority queue also created with the number of vertices with the new node. New node is having the two fields. One is the node field and another one is the cast field. Now we are calling the Dijkstra's method by passing adjacent list and source vertex. Here source vertex is the 0. We are passing here. The source is already defined here. So source is passing and adjacent list we are passing. Here we are having adjacent list with all the vertices. Okay. Now Dijkstra is getting the values, the list of nodes, adjacent list all the vertices, and source is 0. Now we are calculating the distance of 0. Now as of now unknown, distance of 1 unknown, distance of 2. For all the vertices we are assigning the infinity values. Then we are adding the node source into the priority queue. As of now we are adding the node into the priority queue. So priority queue will always have the two values in the node. So node is having, node 1 means we are having the source, I mean cost value and node value, vertex value. Okay, so two fields will be available as per this structure. Right now we are passing the source node into the priority queue. Then we are calculating the distance. As of now the distance to the source is, from the source to source is 0. Then next we are checking the connected size. So connected means the node is connected to the source vertex or not. So now this is connected size is as of now 0. Okay, then not equal to v is 5, right? So v is 5, so it is here 0 not equal to 5. Yes, it is true. Then priority queue we are checking, is it empty? No, in the priority queue source is available. Now we are going to check removing the minimum distance node from the priority queue. So in the priority queue, now minimum distance node we are having a 0. Okay, then we are checking connected dot contains of u. So u is not available still in the connected, because still we didn't add that source vertex into the single source shortest path. Now it is false. If it is false, we are going to add that u. Okay, we are adding that u into the connected. So now we are taking the zeroth vertex into the single source shortest path. Then we are finding the adjacent nodes, adjacent vertices to the vertex 0. Now for vertex 0, we are finding the adjacent vertex edge distance. As of now we are taking the -1, new distance also -1. We are taking the 0 to adjacent dot get u dot size. How many adjacent nodes are there for 0? You look at that: 0 to 1, 0 to 2, 0 to 3. So here we are having the 3, right? So now we are checking the vertex adjacent dot get u of I. 0 to here 0, this is also 0. So dot connected dot contains v dot node. Here v is 0. Okay, it is asking not connected. Connected is not having 0, but it is already having the 0. So it is false. If it is false, then this statement will not execute. Again, for loop is incremented by 1. When it is for loop is incremented by 1, the I will become 1. I will become 1. So adjacent dot get of 0 of 1. So 0 to 1, 0 to 1. Here v dot node is 1. And look at here, v is now 1, right? So not connected contains 1. You look at that, yes, it is not connected, not having the 1 in the connected. Yes. So then if it is like that, then we have to find out v dot cost. V is here 1, right? So v dot cost is here 1, right? So v dot cost is, now we are going to take the, this is the cost value, right? So cost value we are adding that, this is the 9, right? So 9 is the v dot cost edge distance. The new distance is distance of u. Distance of u is already 0, which is calculated earlier. So 0 plus 9. So this is the cost new distance. The new distance is less than that v dot node, right? So v dot node is already, we are having unknown value. If it is the less than that value, right, then we are going to add that new distance into the v dot node. Yes, now the 9 is updated to the 1. So priority queue new node v dot node is added into the priority queue. So priority queue is going to add that vertex 1, right, with the edge cost 9, right? So now this is the 1 comma, so both values will be there, node also will be there, distance also will be there in the priority queue. Okay, so that is the thing. Then again you are increasing the I value. Now I value becomes 2. Then when your I value becomes 2, you have to find out the cost. Okay, so here it is not available in the connected. Yes, you look at that, it is not available in the connected. So you have to take the cost of the 2 is 6. Then new distance for the 6. Okay, already for the distance of u is 0. So 0 plus 6 is 6. So 6 is assigned here to the 2. So now again this is going to be added into the priority queue with node cost 2 and 6. Okay, so this is another value. So like that, again you have to keep on check. So when you keep on checking, the value will be updated. Here 5, here it will be 3, right? So now it is after getting updated, right? Then what it will be happen, again this has to be, this has to be called to update the weights until reaching the number of connected size equal to 5 equal to 5, right? Then if it is reaches here, then it will be stopped the algorithm after finding the shortest edges between all the vertices from source vertex. So here 0 to 0, you look at that, 0 to 0 is 0, 0 to 1 is 8. So 0 to 1 is here, this is 9. So it is going to be updated through this path. So here 6, and 2 are there, so it will be updated with 8. So 0 to 2 is 6, and if you go from any other path, it will come as, you look at that, this will give you 0 to 2 is 9, here it will give 11. So the 0 to 2 is 6 is the minimum cost, and 0 to 3 is 5. If you go this way, it will be 10. Okay, so that's why it is the 5, and 0 to 4 is 3. Only one path is there, 0 to 4 is 3. So this is the way to find out the shortest path from single source to all the sources using Dijkstra's algorithm. Thanks for watching.